Hello, and in today's STM32 programming with a blue pill, we are going to be covering interrupts, specifically the GPIO interrupt. I have already created a project here with all the necessary files copied from the previous project where we had blinking LEDs and buttons. So it's basically a duplicate of the button project. So the first thing we want to do is we want to configure our pins as interrupt. Now you can see here, we can click the pin and then we can say GPIO exit interrupt. So it's going to be exit 8 and it's going to rename the pin, and exit 15. Then we just quickly rename those since we don't retain the name if we change the function of the pin. Okay, now the pins are set up for interrupt method. Now something to note, you can see it says exit 15. And then for PA8, it says exit 8. So what this means is you cannot have the same interrupt on the exit 15 or the exit 8. So on the other ports, you'll see PA15 will also go to the GPIO 15 exit. So you can't have two of the same pin numbers across two ports on the same interrupt vector. Same story with exit 8. That will be the same on PB8 as on PA8, and the same on the PCE, but in total for this particular STM you can only have 16 GPIO interrupts, and you can mix and match them across the ports, but the same pin number cannot be used twice for the same interrupt. Now we need to configure the interrupts, so we can go to our GPIO and then expand that. Then we need to set it as a pull up because the pin is pulled low. And then we need to set the mode. So it's going to be external interrupt mode with falling edge trigger detection because we are going from a high voltage level to a low voltage level. And then the same for the other interrupt. So falling edge with pull up and falling edge trigger with pull up. And now the pin is configured. Now we can save and generate our code. Now in the C main, we can see nothing much else has changed. So we go have a look at the GPIO init, and then we go have a look for our switch pins. Here we can see the switch 1 and 2. You can have the configuration here as GPIO mode interrupt. So the IT is for interrupt, and falling edge GPIO mode, and then it just inits the GPIO. So we can use the same base structure that we have written in the previous tutorials. So then we go to our GPIO hull.cpp. We have that open, and we open the H file. We separate these two and we create a larger function. We separate them so that we have them next to each other so we can easily edit. Just create a few new lines there. We create another class for the ISR, for the external. We're going to say it's DISR as the class, and that is going to inherit the D input. We just change our constructor and destructor, and then we also just copy paste D in constructor and destructor, and we just rename that to DISR to DISR, and then our inherit class over here. Then we are going to create a function in the public space, and we are going to call that void set ISR CB, which stands for callback, and that's going to take a void parameter. That's it, what we're going to create for now. So we say DISR namespace set ISR callback, it returns void parameters. Then at the top of our H file, we're going to create a function pointer with a type def. Our function is going to return void parameters. We point it to a function with the name GPIO ISR CB for callback, and that is going to take in void parameters into its callback. And we take this and we create a private variable of that callback definition. And we say it's underscore CB. In our initialization, we are going to initialize the underscore CB as null. And where we set the ISR, we give it a parameter of GPIO is ISR callback, so the type we defined. We add in that to our ISR callback, and we say underscore CB is equals to CB. So the callback we pass in is equal to our private callback in the GPIO ISR. And then we need a method to call our ISR. So we say void call underscore ISR, and that will take in void parameters as well. Then we just add it to our C file. And then we say if our private callback is equivalent to null, we return, because if it is null and we try to call a function to the null parameter, then it will crash the MCU because we are accessing invalid memory. And then CB we just call with no parameters. Okay, now we need to access the interrupt. So we go to our project tree. We go to our drivers, the STM32F1 series hull driver. We go to our includes, and then we go check in our GPIO.h. We just scroll down, scanning through the functions. Here is our GPIO functions for pin read, write, toggle pin, lock pin, and then we have two functions, which is the GPIO exit hull IRQ handle. So this handles the callback to your interrupt, and then we have the GPIO hull exit callback that passes in the GPIO pin. Now, if we have a look at it in the source file, we see in our GPIO.c, and then we scroll down to the bottom, we can see that the GPIO hull exit callback is declared as weak. So we can override this function if we redeclare it in a C file. So for most interrupts, they will have a weak declaration for the callback, so the function just exists. So we just copy this function, and then we go back to our CPP file. Then at the top, we declare the function as a strong linkage function. So this will now override the other callback function in the .c file because it has strong linkage instead of weak linkage, which is defined with the underscore weak macro. Now we have a issue because we can create multiple objects of the GPIO, and then we need to keep track of which GPIO pin has triggered this ISR. But we can have multiple class instances piping through this function. And this is true for most of the interrupts. So what I'm going to do is I'm going to create a template class, and we just create a header file for that. And I'm going to call it ISR underscore hull.h, and then we finish. And in this ISR hull, we just include main, just so we have access to all the functions. We include vector so that we can create a dynamic list. Then we include the algorithm library. This is so we can use the find function. And now for our template class, we create a template of class, so a class template, and we just call it T, and as per standard usage we declare class ISR, and we create our public function labels and our private function labels. We create a constructor and a destructor. We remove this, and the destructor takes void parameters as well as the constructor. And we add a variable of type std vector, and the vector's type is going to be of t pointer. So we are going to create a list of pointers, and then we're just going to say ISR list. So this is the list of the ISRs we are going to create, and the ISR list is going to be of type class of any type we wish. So now in our constructor, we take our ISR list and then we clear it, and in our destructor, we say if the ISR list size is equivalent to 0, then we just return. We don't need to do anything if the size is 0 because the list is empty. And then we say our ISR list dot erase. So we're going to remove an item now from the list, and that's going to use std find from the algorithm library. We are going to give it the ISR list starting point, so dot begin, and we are going to give it the end of the list, so the end line So for our destructor, we're just going to clear the list as well, since all the instances of this will be cleared if the parent object gets deleted. So we add a function to add something to our list. So we just say void add, and that's going to be of type t star object. We are passing objects to the vector over here, and we say isr list push back. And what do we want to put at the back of the vector? We want to put the current object at the back of the vector. And we say void remove. So this will remove a vector from the object list. And that will also take in a parameter of type t, pointer to object. And we say if our isr list dot size is equivalent to 0, then we just return, because if we don't have anything that can be removed, why should we remove something? Then we say our isr list dot erase, so we are removing the object from the isr list. We say std find from the algorithm library, and then we say isr list dot begin, so we give it the start of the list, and then we need to give it the end of the list and what we need to delete. So that is going to be the current object we're passing in, and that will remove the object from the list. And then finally, we want to be able to get the object that we are looking for. So we say t star, so it returns a pointer to the object. We say get, and that is going to be uint 16 underscore t, and the index of the object that we like to get. And then we say return our isr list with the index parameter. And if our size list is 0, so we have no objects, we have to return null. And then finally, we need to return the size, so the size of the list that we have already created. So that's going to be size underscore t, so our size type. And we just call the function size, and it takes in no parameters. And then simply what we do is we return the isr list size. Because it's a template class, everything is required to be declared in the .h file. Then in our gpio.h, we are going to say hash include isr underscore whole .h. So this includes this template class we just created. Then we're going to take isr. Then we create a object variable from it, and it's going to be of type disr. And we're just going to use the same name as here. So isr list, and this list is going to be static. So it's going to be shared between all the objects that are created of disr. And we can go back to our .cpp file and just globally declare it here. And use a namespace of disr, and that will create us a object list. And we take this, copy it, and in our constructor, we can say the isr list and add the current object, so this, to it, and then disr remove this. So when the object is created, it adds it to the isr list. If the object is destructed, we remove it from the isr list. So now we have a global way of keeping track of where our objects are. Then we need to create a static function of void in, and we say that is trigger underscore pin. And that is going to take in a uint 16 underscore t. And we're going to say that is the gpio underscore pin. Then we declare the static function underneath here. Give it its namespace. And then we say for int I equals 0, comma I less than the disr list dot size. And then we say I plus plus. Now we have a method to iterate through our class. Now we need to call specific functions. So we say if. Now we need to retrieve the pin that we are using. So we say uint 16 underscore t isr list dot get Then we pass it the current index we're looking at, and that will be equals to a get pin function, which we still need to create. And then we say if GPIO pin is equivalent to pin, so we say here pin, if they are equivalent, then we can say DISR and call the ISR that is hooked to the current object. Then we can take this function and put it into our GPIO callback and pass it the GPIO pin. Now we need to add a function to return the pin number. So we simply say in our GPIO base, we say get pin void, and that will return a uint 16. Then we take this from our base class, just declare it here, give it the namespace, and very simple, this returns the underscore pin. Very simple. Now all our functions are created. Let's see if everything builds. Apparently not. I need to rename this to GPIO pin. Let's see if that builds now. Nope. Underscore CB was not declared in the scope. Need to add a namespace over there. Okay. More errors. What are you complaining about? It cannot be used as a function. Bullshit, it can't. If we change this to a uint 16. Oh, return. See if it complains as a uint 16. Let's see what happens if we build now. Oh, we have a successful build. Minor error. So now we can delete our cmain. We delete debug. Okay. So everything is handled. So now what we've implemented is a method that when the GPIO exit callback is called from the underlying controller, then it will automatically pass the pin through to a function in the DISR. The DISR will go and have a look which ISR pin correlates to the pin that we have passed in. And then if the pin matches, then we call our ISR, and that is spelled wrong. So it's going to be call ISR. Let's just fix that. So basically now we have a method of handling multiple pins per object. And then we go to our main.cpp, expand this, remove our LED, and we change our switch 1 to a DISR object. And our DISR object is going to take a parameter of set GPIO ISR callback. We haven't created the callback yet. And then we create our next object of switch 2. And that's also going to be the same. Then we need to create our two callbacks. So that's going to be void SW1 callback, which also takes a void parameter. And then we just duplicate this function. That's going to be switch 2. And we save it. And we pass the callbacks in to our switch functions, just attach each one to the correct object. And now we have callback set. Now we're going to create two variables. Let's say uint32 underscore t. And this is going to be the, let's say, SW1 latch. And that's going to be equals to 0. And since we're calling it from an interrupt, it's going to be a volatile type. So we're telling the compiler, don't optimize this. Then we just duplicate it again for the second switch, same story. And then simply what we're going to do is we're going to increment this every time the switch is pressed. Same story here. And then we create two local variables of the same type just before we enter the while loop. And then we're going to say this one is the state. Same story over here. We say if switch state is not equals to the latch state, and we're going to say a whole underscore delay of, let's say, 200 milliseconds. And then we're going to say also while sw1.read is equals to 0. Then we just add in no operation instructions, so we're just waiting in this loop. Then we save the switch state as the latch state. We take LED1 and we use the toggle function on it. So every time the switch is pressed, the LED state will change from either on to off. And then we duplicate the function again, or duplicate the loop again. We can actually create this as a function, but it's not that important for here. We change everything from switch 1 to switch 2, and then to LED 2, so that we have some separation. Then we quickly just build this and see what it says. No warnings, fantastic. And then we can flash it onto our STM32. Just set your debugger. And now, as you can see on the board, no LEDs are on. If I press the button here, absolutely nothing happens. Why? Okay, let's do some debugging. Okay, so looking over the settings again, I forgot to mention that in the nested vector interrupt controller for the ARM controllers, you need to enable the interrupt on the tick boxes. So that's all we need to do. So we just save here, we let the code generate, and we just delete our main.c again. Yes, I would like to switch the perspective. We quickly run the code again. Okay, see what it does. Okay, now on the board you can see nothing's on. If I press the button, the LED goes on and it stays on. Press it again, the LED goes off and stays off. On, off, other interrupt, on, off. And then on and off. If I press both simultaneously, you can see, well, there's a little bit of a bounce there. I attempted to debounce it, but apparently didn't do a good enough job. If I press both again, see a slight flicker, and then you have an unknown state. But yeah, that is a basic introduction to using interrupts on a STM32 Blue Pill. Like, share, comment, and subscribe is always appreciated. Thank you. Have a nice day.